Hi Aaron, I have been hearing a lot about sampling in my statistics class, but I'm still a bit confused. Can you explain it to me?
Of course, Alex. Sampling is a fundamental concept in statistics. It's how we select a group of individuals from a larger population to study. Samplings allow us to make inference about a population without having to study every single member. There are different methods of sampling, each with its own advantages and use. The first type is probability sampling, and the second type is non-probability sampling.
What probability sampling have?
One common method is simple random sampling. Another method is systematic sampling.
I see. What else?
Then there are certified sampling.
Any another method?
Yes, cluster sampling. Instead of sampling individuals, you randomly select entire group or clusters. This is useful when the population is spread out geographically.
Got it.
Non-probability sampling doesn't give every member a chance of being selected. It's often used for exploratory research. Here are some types: convenience sampling, quota sampling, judgmental sampling, and snowball sampling.
Hi Aaron, I'm trying to understand non-probability sampling for my research class. Can you help me out?
Sure, Alex, I will explain it. Non-probability sampling means selecting samples based on specific criteria rather than randomly. Not everyone in the population has an equal chance of being chosen. Let's look at some type first. We have convenience sampling. This method involves selecting participants who are easy to reach. For example, surveying customers at a coffee shop because they are readily available.
Got it. What's next?
Next is judgment sampling or purposive sampling. Here are the researchers use their expertise to select participants their beliefs are most suitable. For example, choosing experienced psychologists for a study on therapy technique.
Interesting. What about quota sampling?
Quota sampling involves dividing the population into subgroups and then sampling a set number from each group. For instance, ensuring your sample include a specific number of men and women from different age groups.
That makes sense. What's the last type?
Finally, there are snowball sampling. This method is great for reaching hidden or hard to reach population. Initial participants refer others who meet the study criteria. For example, studying a community of local artists by starting with a few and expanding through their network.
Thanks, Aaron. Non-probability sampling include convention, judgment, quota, and snowball sampling. Each has its strength and weakness.
Exactly. Now you are ready to tackle your research. Good luck, Alex.
Thanks, Aaron. See you later.
Alex, we need to figure out how sample size work for our project. Let's pretend we are helping a bank manager determine the number of monthly withdrawals.
Sounds good. Let's say the manager wants to be 95% confident that the estimate is within 400 ringgit of the true average.
Okay, so precision means how close our estimate is to the actual value. Here, it's within 400 ringgit.
And variability tells us how spread out the withdrawal are. If the withdrawal are similar, we need fewer samples. If they vary a lot, we need more.
Exactly, and being 95% confidence means we are pretty sure our estimate is accurate within that 400 ringgit range.
So to get the right sample size, we need to consider precision, variability, and confidence level together.
Right, let's calculate it using data we got.
Let's go.
Great, we got it. We need a sample size of about 200 to be 95% confidence with a 400 ringgit precision.
Perfect. Let's write this up for our project. I'm designing a study on consumer preference, but I'm stuck on the sample size.
Sample size can be tricky. What kind of data are you collecting?
Lot of stuff. Age, income, brand preference, purchase history. It's all over the place.
Multivariate analysis then. That changes things a bit. Usually, a larger sample size is better, but with a multiple variables, it gets more complex.
More complex? How?
Well, if you plan to break your sample into subgroups like different age brackets, you will need a bigger overall sample to ensure each subgroup has enough data for analysis.
Subgroups? That's a good point. Definitely want to compare preference by age.
Pretty much, there are formulas to calculate the ideal size, but it such as a good rule of thumb is to have several times more data points than the number of variables you are analyzing.
So, a bigger sample is the key for both subgroup and complex analysis.
Exactly. The more subgroups, the more data you will need. But the upside of multivariate analysis is that it can identify relationships between all those variables, not just isolated effects.
Okay, that helps a lot. Thanks, Aaron. Time to adjust my sample size calculation. Aaron, this is animation about AI learning are really cool, but sometimes it confuses me. It's talked about two types of error, sampling error and non-sampling error. What's the difference?
Excellent question, Alex. Let's break it down. Imagine you want to know the average height of students in our school.
Okay,
Sampling error happens when you don't choose the perfect group to represent the whole school. Let's say you are the only survey of the basketball team. They'll be taller on average, right? That's a sampling error because it does not reflect the entire student body.
so it's like picking the wrong apples to judge the whole earth.
Exactly. So the non-sampling errors are different. For example, it's when the data itself is flawed, regardlessly of who you survey.
Flavored data? How?
Let's say you can imagine the measuring tool you use to check the student height is faulty. It's consistently at a few centimeters. That's non-sampling error. It affects all the data, not just the sample you choose.
Oh, I see. So sampling error is about who you pick, and non-sampling error is about the quality of the data itself.
Perfect. The animation focus on sampling error because it's crucial for AI learning. The AI needs good, representative data to learn effectively.
This makes so much sense now. Thanks, Aaron.
However, Alex, remember, good data is the key for good results. whether it's AI or any kind of research.